Question 23 gives me A at 3, 5 and B at 7 and 10. So I've drawn that on my coordinate axes here. So A and B are there. And we have a point C at 0, 2. So I've drawn that in green here on the y-axis C. And a point D lies along the line x equals 1 because the coordinate is x is 1, A could be any value. So what I've done is I've drawn a vertical line through x equals 1, and I know that I need to have the C point make a line with that red line. And for part A, it's asking for the line C to D to be parallel. Okay, so if it's parallel, then it's going to be this green line that I've drawn in here. And it looks like it's going to cross somewhere just above 3. Okay, so that gives me a good idea what I'm looking for. So I'm looking for where it's going to cross that D line, where it's that red line, x equals 1, where it's going to make it parallel to the blue line. So how do I set this up? Okay, so I'm going to do this with slopes. So what I'm going to say is that the slope of AB, I'm just going to calculate that using my slope formula, 10 minus 5 over 7 minus 3. That gives me the rise and run. So it gives me a rise and run of 5 over 4. And what I'm going to do then is I'm going to set up the slope between C and D. Now that point there, maybe that point that I've circled in green, we know the x coordinate is 1, that the y coordinate is A. So we're just going to set up the slope formula based on that. So we know that this is going to be equal to the rise, which is the difference in the y coordinates, over the run, which is a difference in the x coordinates. And so these slopes are equal, which then generates an equation which I can solve. There's only one variable to solve in here. Okay, I can solve for A. So I end up with this equation, 5 over 4 is equal to A minus 2 over 1. Okay, well then I'm just gonna, so this is part A, finding parallel lines. Solving for A, I'm just gonna add 2 to both sides. So I'm gonna add 2, and I end up with, that's gonna be 13 over 4. That's gonna be equal to A. So A is equal to 3 1/4, which is about right. That's kind of what I was looking at, and that coordinate there then is 3 1 over 4. Okay, so that's part A. Part B is asking for a perpendicular line. So B, I'm looking for the slope that is perpendicular. So that's that yellow line there I've kind of drawn. It looks like it's kind of crossing just a little bit above 1. So then I'm going to do the same thing here. In this case, though, I'm going to start with my slope of AB. So my slope of A to B, okay, I worked out to 5 over 4. And that's going to be equal to, well, perpendicular means a negative reciprocal. So if I was to calculate the negative reciprocal, it should be equivalent. So the negative reciprocal expression to this one here, and I'm just going to write this in yellow, is going to be negative 1 over A minus 2. So that's one way it can do this, and I can cross multiply and solve for this. So solving for A, I end up with 5A minus 10 equals negative 4. 5A, I'm going to add 10 to both sides, so I end up with positive 6. A is equal to 6 over 5, which is 1.2. And that looks about right. That coordinate in there is going to be at y equals 1.2. Okay, so that looks like is the right coordinate. So then I solve for the A value for both parallel lines and perpendicular lines. Now there's one other way I can do this with the perpendicular, and it might make it a little bit easier to do. I know that perpendicular, a reciprocal in itself multiplies to 1, and since we're talking about negative reciprocal, we can say that the slope of AB times the slope of CD is equal to negative 1. And so I have 5 over 4 times the slope that I calculated for A to B was C to D was A minus 2 over 1, and we can make that equal to negative 1, and I can solve this equation. I end up with the same thing. I end up with 5A minus 10 over 4, so I'm going to multiply both sides by 4, and I get the same result. I get A is still equal to 6 over 5, which is 1.2. Okay, so this is just an alternate way to set up the perpendicular slope equation, okay, where we can multiply the slopes together of perpendicular lines, and we get it equal to negative 1.